Hi, let's talk about datasets and data loaders in Pytorch. Access to data is required when training a neural network, and Pytorch provides an inbuilt set of datasets that you can use. First, let's activate our Conda environment. Next, we want to get into the Python shell. Let's do the required imports. From the Torch Vision package, we import the Datasets module. We also import transforms from the Torch Vision module. And we import matplotlib.pyplot for plotting. Let's extract the fashionMNIST data from the Datasets module by issuing this command. Datasets.fashionMNIST takes in a few arguments. The first is the path where we want to store the extracted data. By setting train equals to true, we are saying we want to download the training data. By setting download equals to true, it will actually download the data. And we set the transform to be transforms.toTensor so that whatever data is extracted, it is converted to a Pytorch tensor. Here it is downloading the data. If we look at the type of trained data, we see it's of class Torch Vision Datasets MNIST fashionMNIST. Now this dataset, if we look at the length of this data, it has around 60,000 samples. And if we look at the first sample, it's a tuple, and the tuple contains the image and the corresponding label. So this dataset contains 60,000 training examples and 10,000 test examples. To load the test examples, we issue a similar command, except that instead of saying train equals to true, we say train equals to false and store that in the test data variable. If we again look at type of test data, it's of type class Torch Vision Datasets MNIST fashionMNIST. We can visualize this data by plotting some of the downloaded images and labels. We can first create a figure. We then extract the image and label from the dataset by saying image label equals train data, let's say sample 0. We look at type image, it's a torch tensor, and similarly type label, it's an integer. If we look at the value, it's label 9 for the first example, train data 0. And if we look at image.shape, it's of size 1 by 28 by 28. So it's a 28 by 28 grayscale image, but the one here represents that it's a single channel image. So we can do plt.imshow, and we can pass in the image, but then we need to remove out the channel dimension by issuing the squeeze function call. And we can say that it's a grayscale image. And then we can set the title to be the string value of the label. And we can do the show command to see what does the image looks like. So here we can see that the first image in the train data is of a shoe, and the shoe has a label value of 9. We can also create custom data sets, and for that Pytorch provides the dataset class, and we would need to override 3 functions: the underscore init function, the underscore length function, underscore get item function to create a custom dataset. After we have retrieved data from the datasets object, when we want to train a neural network using that data, instead of extracting one sample at a time, we generally pass in a batch of examples to the neural network. To help us do this task, Pytorch provides us the data loader capability. So first we do the required import. Then we create a data loader object, pass in the data, pass in the batch size that we want. Let's say we want to extract 8 examples at a time. And if we give shuffle equals to true, it'll shuffle the data when it extracts from the dataset so that the sequence of data samples that are being passed during training are randomized. If we look at type train loader, it's a data loader object. If we look at length of train loader, we see that it has 7,500 in length. That's because 7,500 times 8 is 60,000 samples, and 8 was our batch size. To get the first batch, we can issue this command. Now we can look at what the train features and train labels looks like. So train features is a tensor whose shape is 8 by 1 by 28 by 28. This 8, the first 8 is because the batch size is 8, so there are 8 examples in train features. 1 is the channel dimension and 28 by 28 is the image size. So again we can visualize, let's say, the second image in this case by saying image equals train features 1, and if we look at image.shape, we see it's again of size 128 by 28. So again we can do plt.imshow of image, and then we want to squeeze the channel dimension because we want to show it as a grayscale image. We can set the title to be the string value of train labels 1, and then finally we can do show to see the image. So here we see that the second example is shown. Again the image size is 28 by 28. We can exit and finally make sure that the data folder contains the downloaded data. So we see inside the data folder we have the fashion MNIST data, inside which we have raw data, which then contains the downloaded files.